Okay, when you're doing an optimization problem, you want to get two equations usually. If they don't give you anything, usually you're going to need two equations, okay? You're going to take those two equations, you're going to condense them into one, and then you're going to derive that one equation. And the one that you derive is the one that you're trying to maximize or minimize, or really that's it. You're maximizing or minimizing something, okay? So here's our farmer. He wants to have a rectangular pasture for his cows. One side of the pasture, which is adjacent to the river, requires no fencing. The total area of the pasture must be 125,000 square meters. What dimensions require the least amount of fencing? Okay. What information has he given us? Have they given us? Sorry. The area. So you write the formula down. Area is equal to 125,000. What's the area of a rectangle? Length times width. Length, width. If you don't have a diagram, always draw a diagram. Okay? So 125,000 equals the length times the width. Does everybody agree with that? There's one equation. Congratulations, people. You got about 0.5 of a mark. Or 1 mark. Okay, now, if you've been in my class before, I probably at some point has said, if you have two unknowns, how many equations do you need to solve it? If you have 5 unknowns, you need. If you have 85 million unknowns, you need. Exactly. However many unknowns you have is how many equations you need. So we have to come up with another equation. What's that other equation going to be? Sorry. What do you call that? Perimeter, right? Because they telling us they want to use the least. They want us to use the least amount of fencing. I don't call them primary and secondary. I just get two equations. Just get two equations. That can be a primary if you want it to be. Okay? When they say the least amount of fencing, that means the perimeter. Okay? So what is the perimeter of this thing? 2W plus L, right? Because that's width too. Okay. Now, before you derive it, you only want one unknown. This is the equation we're going to derive because we're trying to minimize the amount of fencing, which is minimizing the perimeter, okay, but keeping the area at 125,000. So I don't want two variables. You do not want two variables. You want one variable. That's when you use this first equation to get rid of one of these variables. It doesn't matter which variable you get rid of. It's your choice. What do you want to get rid of? L? I would get rid of L too. Okay. So how do I get rid of L? Yes, I use the first equation here, and I go 125,000 divided by W equals L. And that means I can then take this and put it right there to get our new equation, which is okay. So there's your equation. Okay. How many variables are in this equation? One. This is what we want to derive because it's only got one variable. Okay. Before I derive it though, because the W's in the denominator, what do I want to do? -1. So I'm going to rewrite it as that. I'm writing derive, I don't care. Derive it. So the derivative of p, so we're doing dp dw is equal to what? What's the derivative of 2w with respect to w? No, just 2. Because remember, if this bottom variable matches that, it's just regular derivatives. So I get 2 minus, so I get that, right? Okay. Does everybody agree with that? How did I get what? No, I'm doing power rule. All right, you drop the -1 down, take away 1 from the exponent. Is everybody good? Okay. Now, what do I do now? Find the what? Why? Because he told you? Yes, because remember, we're trying to what am I saying? We're trying to find the least amount of fencing. So we're trying to minimize this, right? And remember, when you have a curve, the maxes and the mins occur when the derivative is 0. Okay, so you set the derivative equal to 0 and solve it.